Get Happy. Bewusster leben, zufriedener sein. Von und mit Kati Kleff.
Und ich sage hallo ihr Lieben, schön, dass ihr auch an diesem Freitag mit dabei seid. Wie immer hoffe ich, dass es euch gut geht und dass ihr in diesem Moment an einem schönen und an einem sicheren Ort seid. Diese Folge ist keine gewöhnliche, denn heute erscheint die 200. Episode von Get Happy und glaubt mir, ich kann es selbst kaum fassen. Seit dem Oktober 2020 wurde dieser Podcast fast 3 Millionen Mal downgeloadet oder gestreamt. Und für mich persönlich ist Get Happy mittlerweile fast eine eigene Entität mit einem eigenen Bewusstsein. Und ich empfinde es als großes Geschenk, dass ich dankbar und demütig annehme, dass ich diesen Podcast jede Woche in die Welt tragen darf. Dass ich mit so unglaublich faszinierenden, inspirierenden und herzenswarmen Menschen über die Themen sprechen darf, die ich für eine Ganzheitlichkeit zum zufriedenen Leben und für ein friedliches Miteinander für absolut essentiell halte. Also 200 Episoden Get Happy und ihr habt auch was davon. Und was das ist, das verrate ich euch zum Schluss dieser Folge. Mein Gast in der Jubiläumssendung ist ein ganz besonderer. Und dass ich mit ihm sprechen durfte, das hat das Universum eingefädelt, denn geplant war dieser Austausch nicht. Ich hatte das große Vergnügen, ihn im vergangenen November beim Find Your Flow Festival in Basel persönlich kennenzulernen. Und weil er die große Show am Samstag um 10 auf der Hauptbühne eröffnet hat, während ich zeitgleich auf der kleineren Bühne stand und über mein Herzensthema Trauma sprechen durfte, saßen wir morgens um 8:30 gemeinsam im Shuttle auf dem Weg vom Hotel in die Halle. Und wir haben uns gut unterhalten. Er hatte eine Frage, ich konnte ihm in dieser Situation helfen und eine Antwort geben. Wir waren uns sehr sympathisch und dann habe ich mir ein Herz gefasst und habe ihn gefragt, ob er nicht Lust hat, dass wir uns am Nachmittag nochmal hier im Hotel treffen und ob er nicht Lust hat, Gast zu sein in meinem Podcast. Er hat spontan Ja gesagt und so hatte ich die große Ehre, mich mit ihm auszutauschen, eine ganze Stunde lang, über seine persönliche Geschichte, über seinen Werdegang, über die Widerstände, die ihm in all den Jahren immer wieder begegnet sind. Wir sprechen natürlich über die Epigenetik, wir sprechen über die Theorie, dass dieses Leben vielleicht doch nur eine Simulation ist. Wir sprechen über das Universum, über die Evolution des Menschen, über Zellen, wir sprechen über Quantenmechanik und über Frequenzen. Darüber, wie unsere Gedanken und unser Sein unsere Realität kreieren. 1971 machte er seinen Doktortitel in Entwicklungsbiologie an der Universität von Virginia. So begann seine Karriere. In den nächsten Jahren lehrte er an der Universität von Wisconsin, war an der Pennsylvania State University und auch am medizinischen Forschungszentrum der Stanford-Universität, hatte in den 90ern diverse Lehraufträge an verschiedenen Unis und verfasste zahlreiche Forschungsberichte zur Entwicklung von Muskelzellen. 2009 wurde er ausgezeichnet mit dem Goi Peace Award. Und natürlich ist er der Godfather der Epigenetik. Ich wünsche euch viel Vergnügen, ein großes Staunen und natürlich viele wertvolle Erkenntnisse mit dem einzigartigen und fantastischen Bruce Lipton. It is a surprise and yes, it is an honor for me to finally meet you in person. Welcome, Bruce Lipton.
Well, I'm so glad to be here because I met you at a place where you're giving some very important information to a world that's undergoing an evolutionary upheaval and in desperate need of empowerment. So I'm very honored to be here with you, another friend of the world.
Another friend of the work, indeed. Do you remember the first time you've been talking about epigenetics in front of an audience?
The very first time? Yes, it was a very traumatic experience.
Yeah, I can imagine.
It was traumatic because my research contrasted with the academic curriculum. And there's a point where I'm supposed to go in and teach students about genes controlling life, and my research says, no, that's not true. I was in a conundrum, more or less, to say, well, what the hell am I going to do? And then I just one day said, I'm going to resign. And I had tenure, which is a job for life. And I remember being so bold and putting my resignation envelope on the desk of the chairman and saying, I'm resigning. Feeling very, yeah, right. Walked out the door, maybe got 10, 15 feet away from the door and said, what the hell did you just do? You threw away your job. You don't even have a job. You got nothing. What the hell are you doing? But it was the universe pushing me into another place. Mm-hmm. And the big issue that my colleagues had with me was that they would say, explain how this epigenetics, it wasn't called epigenetics at the time because that word didn't come till 1990. Mm-hmm. And they wanted to know the mechanism. I said, well, I don't know the mechanism, but I can predict the results of the experiment, and prediction being the hallmark of science. I said, well, that should be enough information right there. But no, because they're invested in genes. Everybody was in the genes. That was the whole world uprising of genetic engineering and all that kind of stuff. So my idea that the membrane, actually I didn't have the idea of the membrane at that moment. I had the idea that genes did not control this behavior. Mm-hmm. And of course with the mission of how does it work? I don't know. But I had time because I wasn't employed.
Mm-hmm. How old were you?
Oh my God, I don't know. 40-something, I guess.
A real pioneer.
Well, this was 1967,
Wow.
Okay, 68, around that moment. And so I was now, of course, preoccupied with how can such an event occur? Mm-hmm. Well, it started off with a very simple insight. The chemistry I was adding to the culture dish must have gotten through the signal, must have gotten into the cell because it had to affect the interior of the cell. Mm-hmm. And of course, the first thing as being a cell biologist, it's like, well, you have to go through the membrane. And at that time, around that time, I started noticing something very interesting because a large number of papers I was reading talked about IMPs, integral membrane proteins. The word wasn't there, and all of a sudden I started seeing it in this article, that article, and everything. So integral membrane proteins, I started looking it up and started to recognize in that simple bilayer membrane that biologists have always seen, there are proteins stuck in there that are carrying out functions. And it's like, And then I started to realize, well, there were two classes of proteins. Proteins that were receivers of environmental information, and proteins that were engaging functions inside the cell. Mm-hmm. And so I started focusing on this, and I started to realize, wait a minute, a receptor is connected to what is called a channel. The receptor reads the signal from the environment. The channel is a protein that relays the signal into the cell. So I started focusing on that. And I was like, yeah, this is going to make sense. This makes a lot of sense. But I didn't realize how much sense it made at that moment because something changed that was so dramatic. My life went in a whole different direction. Mm-hmm. And that is because I was trying to define the membrane, okay? And conventional definition would be like a receptor, effector, integral membrane protein complex, which is like cool. But as I started to study it, I started that the channel was opening up and sending a current through. And I thought, oh, wait a minute. So the receptor is receiving a signal, and then it opens up a channel. And so I wrote this definition just cold. The membrane is a liquid crystal, that's character. The membrane is a liquid crystal with receptors and channels, and that there's a current difference between the inside and the outside, membrane potential. Mm-hmm. And that when the channel opened up, it would drive an electric current into the cell, which each channel, when it opens, has a different frequency of what the electrons run through. So, like there are 6, 7 sodium channels. They're all past sodium, but they do it with different frequencies of the energy going through. Mm-hmm. So they pass sodium, but this has a frequency of X and this one has a frequency of Y. So the signals coming in are really at a level of some complexity. I'm so preoccupied with this. And then I write this equation and the world changed for me. Mm-hmm. I wrote the following. The membrane is a liquid crystal semiconductor with receptors and channels. The semi comes in is this. Not everything goes through a channel. There are sodium channels, potassium channels, glucose channels. Point is this. It's not a non-conductor. It's not a full conductor. So by definition, it's called a semiconductor because it only conducts certain things. I remember vividly writing this. And I wrote, the membrane is a liquid crystal semiconductor with receptors and channels. I said, boy, that sounds familiar. And it was 1985 because I had just bought my first Macintosh computer. Mm-hmm. And on the desk next to my Macintosh computer was a book called Understanding Your Microprocessor, a simple book from Radio Shack. I said, wait, I read something like that. I said, oh my God, I opened up the book. And right in the introduction, the definition of a computer chip is a crystal semiconductor with gates and channels.
You've got to be kidding me.
And I stopped for a second.
Wow.
So gates and channels, well, receptor and a gate is a definition, it's the same thing. And then I said, oh my Jesus, the membrane is a computer chip. And the receptor is an input, the channel is an output. Mm-hmm. Well, in computer technology, the code is I/O, input/output. What is it? A bit of data. And I said, oh my God, the cell membrane has all these bits of data. Mm-hmm. And it's a chip that responds to an environmental signal and adjusts the mechanism inside to conform to the signal. Mm-hmm. And it was like, oh my God, the membrane's a chip. Which then led to, oh my God, the nucleus is a hard drive with programs in it. But what I saw with my results was, it wasn't read-only programs. Depending on the chemistry of the culture medium, it would have different consequences. And all of a sudden, it's like, it became read-write membrane. Mm-hmm. And all of a sudden, the whole world changed because I said, oh my God, a cell is a computer chip. and its programming is based on the environment. And this is how organisms adapt to the environment depending on what programs they're running in their membranes and adjust to whatever frequencies, environmental influences are in each one. And it's like, oh my God. Because then all of a sudden, the theory of evolution came in. Mm-hmm. I said, what is it? Well, evolution we always thought was based on genes, Darwinian theory, neo-Darwinian theory, molecules of Darwin, okay? And they always talked about the fact that genes were the metric of evolution. And I was to find out subsequently that when the Human Genome Project came out, that the human had so few genes, 22,000 genes, compared to the anticipated 100,000 genes, which was conventional science perception, which meant, wait, the whole thing is wrong. Evolution isn't based on the genes. We have the same number of genes as primitive organisms have.
I think we just have a little more genes than an apple.
It's funny because plants have apparently a higher gene concentration than animals, okay?
think about this?
One of the things that always catches me is because one of the research animals is a worm called Caenorhabditis elegans. It's a worm of 1,024 cells. And it's a great research thing because they have behavior. And they have a very small brain of 300-some cells. And so the idea is, well, if you reduce it small enough, you can see how it works. Reductionism. Mm-hmm. And so that's the same number of genes that the worm has. So a human has the same number of genes as a worm. Wow. Well, that throws a whole monkey wrench into the game of genetics being a level of measuring evolution. It's not measured by genes. But then it was Lamarck's work, because Lamarck said that, well, Darwin's theory was emphasizing heredity. Mm-hmm. Lamarck, who wrote the first scientific theory of evolution, which has to be so emphasized because everyone said Darwin was 50 years after the publication of mm-hmm. evolution. The drive force in Lamarck's perception is organisms fit the environment. Mm-hmm. So is that chance? Like, no, it's not chance. Somehow the organisms are adjusting to the environment. Well, if they're adjusting to the environment, then the environment must be influencing the genetics and the behavior of the cell. Mm-hmm. Okay? So I started following that. I'll remember this too, because I started looking at the membrane. It's like, this is so cool. I was at Stanford. I went to the library, and I wanted to look up evolution. And there was a whole rack of books. Darwinian evolution, Darwinian evolution, Darwinian evolution, Darwinian evolution. Everything was Darwinian. 4 or 5 shelves. And at the very bottom in the lower right corner, there was a very thin book. And all of a sudden the name skips me right now, but it was Harold Morowitz. Harold Morowitz wrote a book, and it was on membranes. And he talked about how membranes were, the sort of the creation of life, because everyone says, oh, life is in that primeval pool with all the molecules moving around. I said, that's not life. Why? You have to have control, or there's no life. Mm-hmm. And you can't have a control in an open swimming pool. Mm-hmm. It's a membrane that creates an environment. And when the environment is contained, you can control it. Mm-hmm. So life started when membranes, which would spontaneously form, because you can shake up the lipids, and they will spontaneously create a membrane. That and Morowitz brought in the idea that crystals, like little crystal, like mineral crystal size, would get caught in the membrane. And then he would talk about the fact that light would hit those crystals, but it would create an energy response, which then produced energy inside the envelope, the protocell, mm-hmm. which is giving how life could be energized and created from the energy. Okay, blah, 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 blah. What was the point? He emphasized the only book on the whole damn thing that emphasized that membranes might be very important in this evolution. And so that, of course, attracted my attention. I started putting all the pieces together, and I started to recognize, oh my God, the evolutionary story of Lamarck is the most correct one, that the environmental signals get picked up by the bits of data. The bits of data then control the behavior and the genetics of the cell. And all of a sudden I said, oh my God, evolution is what? Maximizing the membrane. And it's an interesting story, because it's not a straight evolutionary path, like, oh, one goes blah, 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 no, like that. And the reason is this.
It's a kind of communication, right?
Well, it's a communication, but how can you, it's surface area. How can you make membrane? Well, the point is this. Bacteria are, I call them invertebrates, mm-hmm. because the capsule that gives them the structure is on the outside. So a bacterium has a certain amount of volume, and all the functions have to be in there. And you can't have just solid membrane, you need the cytoplasm with all the other things. But I said, well, how much membrane can you put inside a bacterium? And the answer, it's very limited. Because it's a confined space. And I said, oh my God, the first evolution was the evolution of a bacterium membrane expanding. Bacteria live in colonies. You know why? Because outside of the proteins in the membrane that provide for the basic physiology, growth, and all those things, bacteria can have knowledge with an extra piece of DNA, okay? And this extra piece of DNA is generally, they're called plasmids, okay? And the fact is, they can have 1,000 plasmids, but they can only have 5 or 6 different versions. Mm-hmm. So the number of plasmids is not limited how many, but the number limits how many different ones. And it's like, oh, Jesus. Because the plasmids carries the bits of data of learning, okay? And so the plasmids were responding to, the bacteria learn. You can put bacteria in oil, and at some point they eat oil, okay? So they're evolving. Mm-hmm. And the plasmids...
Well, they fit to the environment, right? They want to survive, so they find a way to survive in the environment.
They adjust that way.
Yeah.
So plasmids, but the issue is this. Well, let's say I create a plasmid that resists penicillin. Mm-hmm. But you have 6 plasmids of dealing with iron, some oil, what else, was in the environment. You can't have another plasmid. Mm-hmm. But in a process where finger-like extensions of bacteria, like Filopodia, they can touch each other and they can transfer a plasmid. So if I touch your filament with my filament, you already have the maximum amount, but I can give you temporarily, you can't reproduce it, but I can give you the plasmid to make these penicillin-resistant proteins. Mm-hmm. And all of a sudden I said, oh, Jesus, bacteria live in community because each bacterium can only learn X number of things. And so to really get a picture of the world and deal with it, you need a number of bacteria, each representing 6 different kinds of things that you can all share together. So I said, oh. So the membrane gets filled up. It can only put 6 plasmids or 7 plasmids. Why? Because a plasmid must put a bit of data into the membrane. So the point is, well, how much excess membrane is there outside of housekeeping functions? It's a very small amount. Mm-hmm. So all of a sudden I said, yeah, I could put 6 new bits of data in. So it's like, oh, evolution stopped. It couldn't make any more membrane. Mm-hmm. So I said, but it didn't stop the bacteria I just talked about. Community, share awareness. Phase 1, make the smartest bacterium. Phase 2, put the individuals together to share the awareness because they each have a limited amount of membrane, but the more individuals is adding more membrane, okay? Mm-hmm. And then something is created from these communities of bacteria that have different functions. They put a membrane around themselves. It's called a biofilm. They control an environment because the membrane allows them to set the pH, the aspects of adjustment. Mm-hmm. pH, the chemistry, the ions, all these other things necessary. You have to control it. And so a community of bacteria get together with different functions, and they put a membrane around themselves. And I said, oh, Jesus. Then one of those bacteria becomes the collector of the DNA from all the other bacteria, because they all don't have to make their own DNA anymore. Put it into one double membrane nucleus, which is a double bacteria, double membrane organism, double membrane nucleus. Apparently, one of the bacteria became the receptacle of receiving the DNA from the other bacteria. Now, not all of the bacteria, you see, if I put the DNA into this one bacterium, I don't need a copy of me anymore because the new one can make the copy of what I do.
Mm-hmm. I get that. Mm-hmm.
So that a number of bacteria came in, but later they disappear because you don't need the individual bacteria if you have a nucleus creating the functions that all the individuals have, except for one set of bacteria, mitochondria, because they needed their own DNA to do it. So they're the only bacteria that came into that biofilm. You couldn't get rid of them as individual units because as individual units, their function was the generation of that respiration energy. So I thought, oh, guess what? Oh, shit. A biofilm becomes an amoeba. Why? Now it's this massive membrane compared to the little membranes inside. Now it's got this massive membrane. And one of them becomes a nucleus, other ones become mitochondria. The rest of them, their functions are taken over by the DNA in the nucleus. And the biggest thing that was different was the skeleton was on the inside, microtubules. And microtubules were like tent poles. And as they spread up, they lifted the membrane like a tent. And all of a sudden it says, my God, you can look how much membrane you could have with the skeleton on the inside. And I said, yeah, but guess what? The cells got big, the membranes got loaded with so much information, got very smart, but there's a point. A cell can't get past a certain size because, analogy, a water balloon. A balloon, you put some water in it. Mm-hmm. Put a small amount of water, you could throw the balloon around all day, no problem. Put a large quantity of water, you just try and throw it, and it rips, and then it's done. A cell, being that balloon, says it can only get to a certain size. I said, oh my God, phase one, again, make the smartest individual. Mm-hmm. First you make the smartest bacterium, then you make the community. New organism, amoeba. Make the smartest amoeba. The only way it can enhance awareness is join the community. And that's when multicellular organisms were created because they could share awareness.
And here we are, 8,000 people in Basel, being an organism.
It is. This is what the point is, because if you go follow this up, then I say, so what? I said, well, what do you think a human is? A community of 50 trillion amoebas sharing awareness. Mm-hmm. But then partitioning out the functions. So the awareness then gets localized to what? A structure called the brain, which is all surface. And it's interesting because if you look at it like a rat brain, and you cut through the skull, it's just around like a vesicle, okay? But then you get to the human, and I say, well, oh my God, it's an analogy to the bacterium. The skull is containing this, and you can only put so much membrane in a skull. So the brain is not now a vesicle. A brain is folded, sulky and gyri. Why? Surface area. The more surface area, but then you maximize it. I go, oh my God, you can't make a smarter human. Phase one, make the smartest human. Phase two, put them together in community. And then what? The community becomes so connected and integrated, it itself is a new organism, but now it's called humanity. Mm. And the earth is a cell, and humanity. And the point about it is, well, what do you think would happen next? And the answer is, there are alien planets all over the place, each one a cell. Next level of evolution, you made the smartest Earth you can make. Now you hook up with all the other ones. And then there's an interstellar organism at that point.
So we are part of unbelievable, huge organism of, we might know the big secret after we left this planet and this life.
Yeah, you see, it's just because it all becomes so beautiful.
Yeah.
It was the same evening, because it was the evening that changed my entire life. So now all of a sudden it's like, oh my God, a theory of evolution based on something you can measure, because you can measure surface area, and surface area becomes a connection of awareness. The more surface, the more awareness. All of a sudden it's like, oh my God, a theory of evolution with a mathematical foundation, which is not in Darwinian theory. And math is required really to understand. All of a sudden it's like, oh my God, you can measure awareness by surface area. Okay, and every level I talked about was what? More surface area, maximizing, then creating community, then maximize, then creating community, a repetition of the same pattern. And on that very same night, I'm just like blown away at this moment. It's like my whole life is like, holy shit, everything starts to make sense.
Because there was a lot of resistance, right? I mean, we can speak about that today in the year 2024, but that hasn't always been this way.
Not in that early period, 1970. No, it was not possible.
Yeah.
Okay, so then the biggest thing of that night, that I thought that was, you couldn't top that, a whole theory of evolution in my hands, okay? And it's like, oh shit. So what? I can't put my cells into your body and you can't put your cells into my body. I say, why? Because the immune system recognizes the difference. And the immune system recognizes physical things, viruses, bacteria, parasites. So if it looks at my cell, if it looks at my cell in your body, your immune system looks at it and says not self. It's seeing something that is your self versus myself. I'm sorry, I kept hitting the microphone right there. Okay, because this gets exciting. I said, why? What's the difference between two people? Why can't we exchange cells? Because each of us have an identity. I go, yeah, but where's the identity? It's called self-receptors. I go, what's the point? I say, the only reason that term came up was because when they want to transplant an organ from one person to another, there are a set of receptors that are called self-receptors. It's a combination lock-like thing. And so they do what's called tissue matching. I got 10 people looking for a heart. I got the owner of the heart's self-receptors, and now I look at the self-receptors on all of the other people. Now, there's not going to be anybody with the same set, but there can be overlap. And if there's overlap, that means there's less immune resistance. So they pick the recipient of a transplant. They pick the recipient which has the best overlap, because that means that they're more likely to not reject the graft right away. So I'm saying, oh my God, self-receptors. They're looking at it for stupid tissue matching, and it's like, they're called receptors. What are receptors? Receivers. And all of a sudden, it said, oh my God. And this has to, you have to know a little quantum physics about vibration and frequency, because receptors read vibration. And all of a sudden I said, oh my God, I'm receiving a broadcast on my self-receptors that you're not receiving on your self-receptors. You have your own broadcast. Every person is receiving a vibrational signature unique to them. There's no two people with the same set of receptors.
Does it mean that not two single people have the same frequency? So everybody has a individual?
No, it's not the same frequencies. They're matching frequencies to a certain degree, but you can't match. I mean, there's only, I forgot how many there are, but you can't. There's no way you match all of them. You can only match 1%.
Okay.
Okay. And so what it's like is there's a field of energy. And it has all these frequencies in it. And so it's like, consider a radio, and you got the band, let's say AM radio. And as you turn the knob, here's a frequency for station 1. Station number 2 has a different frequency. Station 3 has a different frequency. They all came from the same field, but they only each respond to a certain frequency. And then, never forget it, my life had been coming from my head, mental work. And the moment I recognized what I'm going to tell you, I had what I like to jokingly call a heart orgasm. I go, why?
Nice.
I said, because all of a sudden my heart started aching. I could feel it, and tears were running down my face. Why? Because I just saw something. I saw that spirit enters the body through a set of self-receptors, and no two people are receiving the same broadcast. And therefore, our identity is not in the cell. Our identity is broadcast to the cell and received by these antennas, which immediately goes to, you can't die, you're not even in here. It's like, oh, spirituality as a reality of science, no bullshit, religion, nothing. It was like, oh my God, I'm a spiritual entity. I'm immortal. I can't die. Why? I'm not in here. The analogy that I give people, the body is a television, and it's got an antenna, and it downloads a show. And I say, now you're looking at the Bruce TV. And I go, but the show isn't in the TV, the show comes to the TV. And all of a sudden it's like a whole picture of everything came together. The whole damn world, everything was like the key that unlocked everything.
What do you think about this simulation theory?
The idea is it could be totally real because consciousness is not a physical thing. And physics since 1927, Max Planck, physicist and founding father, the mind is the creator of all matter. Okay? And matter is only an illusion because matter is energy. And so the whole thing comes around, it's like, oh my God. Well, we're here playing. And that's why I say, then why are we here? Because it is a simulation in a sense. But my consciousness is manifesting an experience. And I'm creating, we're all creating, okay? And then, you know, and all this is happening, in about 3 hours of, here's the theory of evolution, here's the science of spirituality, all it's like,
Quantum mechanics.
I was just like, oh my God, anything you want to talk about is in this story. And the beautiful part about all that was, why are we here? To create. Like, oh shit. Oh, because religion says we're here to live our place of morality, to see if we're worthy to go to heaven, the creative place. I say, heaven's not the creative place. This is the creative place because we have a virtual reality suit.
And I think Earth is heaven when we create on Earth.
That's what the whole story was. That's what the honeymoon effect was all about. It says, my God, we have heaven on earth, but your programming is keeping you from getting there. And bastards that knew the programming created the interface for them to separate us. And that would be the Jesuits in 400 years ago when they said, and they knew this, and it's accurate, whatever they knew it. They said to their followers, same thing 400 years, give me a child until it is 7 and I will show you the man. I go, what an interesting thing. Because 7 years is the amount of time we're in theta, which is programming. And then 95% of the rest of our life comes from the program. So they already knew, if I can program your first 7 years, I own the rest of your life. And they did. They created Catholic school to program. And that was the beginning. Now the programming is much more outrageously effective than what the Jesuits could have ever thought as programming. I tell people, imagine, I can show you a picture of an infant walking with an iPad, using it as a program. An infant. I said, that is programming. You can see it right there.
It's become even worse because of iPads and iPhones. And I always try to explain to people that we don't, I mean, there is this discussion about free will, that we do not choose certain things, but our subconscious is running the show.
95% is what science has come down to. 95% of our day is subconscious program, 5% is conscious. Conscious is creative, subconscious is habit, And what's the point? We think we're creating our lives, but only 5% of it is coming from us.
It's
95% is coming from the program. So we're not creating our lives, we're creating somebody's program.
Yeah.
And the only way out is to know this so you can get the hell out of the program with consciousness, because nobody knows, the average person has any idea of what the hell we're talking about.
Right.
They believe they're just, I wanted to be happy, but there's problems and these problems, I'm a victim, you know, those people interfered with my happiness. I say, no, you were projecting the problem with your subconscious program that you can't see because it's invisible to the person who's playing the program.
Right.
Okay? So
I mean, consciousness is always the first door that has to open up.
Consciousness, that was Max Planck.
Yeah.
Max Planck. Consciousness is creating a material experience. No other thing, consciousness is doing it. And I used an article from 2016, Nature. Mm-hmm. And Nature, the most prestigious of all the scientific journals, was an article called The Mental Universe by Richard Conn Henry, a physicist. And I used it in the lecture because I said, you don't have to read the article. All you need to read is the last sentence.
What was it?
The universe is immaterial. It's mental and spiritual. Live and enjoy.
That's very beautiful.
It's immaterial. It's not made out of matter. It's made out of energy. And it's mental and spiritual. Mm-hmm. What the hell does that mean? And so, is this a simulation? Well, in a sense, yeah, because it only exists by the collective creativity. Mm-hmm.
I talked to a physician, not a physician, and an author. She wrote about quantum physics, a German book which was very popular in Germany. And I told them at the end of the interview, I said, every day I leave my house wondering for a little second, will the house still be there when I leave it?
This is such a true...
When I stop watching it, and when I stop believing
isn't
that it's there.
The cat, I forgot the physicist's name, the cat in the box in space.
Yeah.
It was like, there's a cat and there's a bottle of poison or something, and the question is, the cat alive or dead? It says you can only tell when you see it.
Exactly.
Yeah. So you can't answer the question.
The observer effect.
You have to observe it, then you can answer the question. Right. Yeah. So.
And we observe with our thoughts too. We do not just observe with our eyes, but with our beliefs,
you
right?
observe. You can feel somebody's energy.
Yeah.
You observe with the energy field. This is one of the biggest problems for people, is because many of us, when we were young, we were programmed not to go by your feelings. And I go, that was the greatest mistake in the world, because your feelings, life is energy. Feelings are regulators of the energy. Mm-hmm. Good feelings, the energy goes up. Bad feelings, the energy goes down. Okay? Mm-hmm. And so...
Dissociated feelings, energy is stuck in the body. Right?
It's not really stuck, you see, because they say, oh, well, you've got that this structure is stuck. I say, it's not the structure, it's the field. Mm-hmm. Mm-hmm. You change the field, it's not stuck. Mm-hmm. It's only stuck if you don't change the field. And Einstein quote, the field is the sole generating factor of matter. Mm-hmm. Okay? And I show them to illustrate that. I tell them I make iron filings with a file, make a pile, put it in a salt shaker, sprinkle on a piece of paper, show them a picture of random pile of iron filings, every time, random. But then I put a magnet underneath the piece of paper. Now when I sprinkle the iron filings, it forms that elaborate, magnetic field. And the point of this experiment was simple. Matter alone, no structure. Matter plus field equals structure. Mm-hmm. Okay? And that's the quote. It's the field is the shaper of this, okay? And so I show them that, and then just to help them along a little bit. I said, well, instead of iron filings on these black dots of iron, I said, consider them to be cancer cells. I say, why? Where'd the cancer come from? Well, without looking at the field, without quantum physics, with conventional physics, there must be something in the cell that causes cancer. So they were looking for something physical in the cancer, and they came up with oncogenes, cancer genes, BRCA gene, as an example, cancer gene, okay? And the fact was, I say,
it's in the field.
It was the field.
Yeah.
It's not in the cell. And I say, look, nearly half the women that have the BRCA gene never got the cancer. What does that mean? The gene doesn't cause cancer. Something else activates the gene. That's where the cancer comes from. And so to get people out of this, I'm a victim of my genetics, because then it goes all the way back to the beginning of what I was talking about, epigenetics. And now, I used a paper yesterday, 9 out of 10 cancers are lifestyle.
Which is lifestyle? What parts of lifestyle for you are fundamental?
There's different lifestyles. There's stuff you put into your body,
so
and there's stuff what you react with. Food, nutrients, all this kind of stuff. Yeah, but lifestyle is stress or happiness and joy or whatever you're doing and all these other things. So lifestyle isn't, just what you eat. No, it's how you interface this world. Mm-hmm. So it's you dealing with the environment is really what this really comes to represent at this point. Lifestyle. Mm-hmm. How are you dealing with your world from every level? From the food to the associations to the environment, all these different things. Mm-hmm. But the point is, it's not genes. Mm-hmm. And then why is that important? Because if it's genes, then you're stuck with the gene. But if it's not genes, it's environment. Well, you can adjust the environment. We went from victim of genetics to masters, because we are the ones that control the environment, which through the membrane chip activates the gene programs and can not just activate them, but rewrite them based on the signals coming in.
Mm-hmm. Which gives us a big gift of responsibility.
Yes, and people don't want to really do that a lot.
Isn't that crazy?
Because it's like, I didn't make my own cancer. I got the cancer. I
get that, because people feel guilty very quickly. You know?
Now let me resolve that, because if you're going to deal with it, I know how to deal with it. There are words, let's use a couple: guilty, shame, blame, these words. I say shame or guilt means you did something that was wrong. But then I say, well, that must mean you knew what was right and you knew what was wrong, and then chose to do the wrong one. But what if you have no knowledge of what is right or wrong? Mm-hmm. Then how can I blame you for what happened, because no one gave you any awareness to what was going on? And so I cannot say, I blame you for cancer. Why? You didn't know what cancer was all about. No one gave you any information. Mm-hmm. A lack of knowledge is a lack of power.
This is what's happening when we are kids. We always think it's our fault, it's our guilt, but nobody corrects us and say, it's not your fault.
No, because they don't know any better either.
Right.
So that's the whole issue. If the parents don't know any better, the kids can't do any better than that. Mm-hmm. And why? Because the limiting of awareness. Mm-hmm. And the powers that be today limit people's awareness so that they have control over the people. Mm-hmm. Medical school is an extension of the pharmaceutical industry. Why? How much teaching of alternative medicine is taught in medical school?
Zero.
Why not? Because if you used alternative medicine, you wouldn't buy the drugs. So the drug companies said, that's not part of the curriculum. Out the window. Mm-hmm. Why? They're manipulating the whole goddamn thing. So even doctors get programmed into this belief system. Why? you want to have a degree? You memorize 99% of what I just said. And if you don't follow what I just said, we take away your degree. Yeah, after you put $500,000 into an education, you better damn well follow it, because that would waste a lot of money.
But times are changing, aren't they?
Yeah, because we're finding a new form. It used to be called alternative, complementary. It is now taken on integrated or functional medicine, because it's being taken in reluctantly. They're not like, oh, open the doors and let's bring in complementary healing in here. It's like, nah. You know, so, and your work with trauma becomes important, and exactly the reason is this. And I lecture about it yesterday, everywhere I lecture about it. I go, simply what? I show them I put 2 petri dishes. One, I put nutrients in front of the cell. The other, I put toxins in front of the cell. I say, now put them back in the incubator. When I take them back out of the incubator, where are the cells? Well, obviously, when there were nutrients, the cells went to the nutrients. When there were toxins, they went away from the signal, okay? Secondly, if it's a positive signal, you go to the signal with your arms open to take it in, assimilate. If it's a negative signal, you don't go to it, you go away from it, but you also close yourself down in protection. So guess what? You can't be in protection and growth at the same time. Because you can't go forwards and backwards at the same time. You can't be open and closed at the same time.
Right. A body in survival won't evolve and change.
It's closed down. Protection shuts you down. But protection is a death thing. Why? Well, I always joke. I say, look, a long time ago in the U.S., when we were afraid of the Russians, we built bomb shelters. And what do you put in the bomb shelter? You put food and water and blah, blah, blah. You put that in there. The only experience we ever had with bomb shelter was air raid test. Sirens go off, work stops, people go into the bomb shelter. 15 minutes later, all clear, everybody back out, back to work again. I say, yeah, but consider this. What if you went into the bomb shelter and there was no all clear? Or what does that mean? I go, how long can you stay alive? How much food did you leave in there? How much water do you have in there? And all of a sudden you start to say, can't stay in protection past a certain point of time because you will die in protection.
I get goosebumps, yeah.
So, so there's a biological, cellular understanding of all this stuff. I mean, look at the cells. I learned everything from watching the cells. We are cells. There's not, ready? Not one new function in a human body that wasn't already present in most of our cells with nuclei. Cells have respiration, digestion, excretion, musculoskeletal, endocrine, nervous system, immune system. Cells have an immune system. Okay, so what's new here? Just a massive amount of data about all of this stuff.
I used to say that this body is just like a supercomputer. It's so brilliant and so perfect.
It's beyond what we can understand.
Yeah.
And the idea was, trained as a conventional scientist, we take things apart to see how they work. It's called reductionism. I reached the end of reductionism, meaning what? Receptor, effector, receptor channel. I go, why? Because that's a unit of perception. That's what it does, by definition. I go, so what? Well, what if I break it apart, take it apart, and I say, no more perception, game over, done. That was number one. Then number two was, wait, there are 100,000 of these bits of data on a cell. You want to know what the cell's going to do? You can't look at one of these things. You have to look at all of these things. I hit the bottom, and then straight up to holism. Reductionism, bottom, you can't, now that I showed you how it works, you need all of them. back to holism again. So that was an interesting U-turn. That was a very difficult. No, it wasn't difficult. It was fun. So now, let's go back to the first question that should have been answered in about 30 seconds, okay?
I mean, I would like to know how you feel personally, that today you are capable of speaking in front of 8,000 people and they are really interested in evolving, and it's such an exciting time to be alive.
I'm a student.
Mm-hmm. Everyone is.
No, I'm a student of this that I talk about. I'm only relaying what I learned as a student, okay? And the fact is, it's a teaching I acquired. And then I realized a lot of people need this teaching. And then I had a mission statement. Talk to as many people that want to hear this story. And then, and the story, as I said, look, we were just talking, I don't know how long that was. That was an introduction to this thing, but this is a whole...
It's not even an hour, but we could speak for 6 or 7 hours probably.
So, so let me answer the first question, because that was a great question. What happened my first presentation of this material?
Yeah.
Well, I needed, for my satisfaction, I wanted a scientific audience. And I'm not in the university anymore. I resigned my tenured position. But I wanted a community, so I called up my old department. And a friend of mine at that point was now the chairman, and I said, I'd like to come back and give a talk. And okay, they don't, it's sort of, you were in the fraternity, you left, don't come back. But they said, okay, come on a Wednesday seminar. Wednesday seminar was the weekly seminar where everybody brings their bag of lunch up and they sit around the big tables and some guy talks in the front and half of them are having, hey, what'd you do last week, this week, their social hour. But I thought, what the hell, it's an opportunity. So I go and provide this Wednesday seminar. All of my former colleagues are in the room. All of the graduate students are in the room. It's filled up. And I start giving my talk about the membrane as an information processor. At the very end, a minute or so before the very end, it dawned on me as I was lecturing, I looked and I said, nobody ate lunch. Nobody did anything. They sat there with looking at me like I came from outer space. I didn't realize what was happening until this. A minute later, I say, thank you very much. This is the response. It was dead silence. And they sat there and they looked at me. Nobody said a word. It was dead silent. And I'll never forget, there was a guy in the left corner in the back and he went twice. And they all looked at him and he put his hands down.
Oh my God, that was traumatizing.
Well, it was traumatizing because the next thing is they all stood up like a conductor. And they all walked out.
Wow.
Not one of my colleagues even stayed to ask me a question. I was in the room alone. And then I got afraid. I said, what if I'm crazy? Because crazy people think they're right. What if I'm crazy? I got scared enough to fly from Wisconsin back to Virginia where I got my PhD. And I wanted to meet with some of the faculty on my committee. And the one that changed my whole experience was I met with one of the top cell biologists for the world at that time, Lenny Rubin. And I was sitting on that little chair in front of his massive desk with him in the big wing-back chair, professor. Even though I was a former professor, but now I'm reduced to the little kid sitting in the chair in front of the professor. And I say, Lenny, I want to tell you my idea, and I want you to tell me, what's wrong with it. So I lay out the story of the membrane and all that. And then he sits in his chair. Well, Bruce, it's not what we're thinking. I go, Lenny, I know it's not what you're thinking. I want you to tell me what's wrong with it so I can get the hell out of it. I'm not going to make myself an idiot. Well, Bruce, it's too simple. I started to laugh. Like, no, I am a crazy person. I'm laughing. He's looking at me like, like, what? I said, Lenny, my first week in graduate school, you guys taught me something called Occam's razor. The simplest hypothesis is the best and should be considered before any other hypothesis. If it's too simple, Lenny, I accept that. Thank you very much. And then I went out and started talking, but I had a fear. One day I would go out in some audience and start talking, and somebody will stand up, yes, but Bruce, blah, 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 is wrong. And I would feel like, ah. So for the first year or two, I was very nervous because I was waiting for somebody to come up and finally tell me what was wrong with my idea, but nobody ever did. Mm-hmm. And then it got to the point where I just kept talking and then not thinking about it anymore. And here I am today. Yeah.
Here you are.
But the first one was trauma. My first lecture was trauma. I mean, not one person stayed in that room.
It's so terrible.
And these were my colleagues, and it was like, uh-oh.
It feels like a scene from a Hollywood movie.
Now here it comes, because I felt maybe I have to get back into academia. So I thought, well, I'm going to apply to some schools, but I'm going to pick middle schools because Wisconsin is near the top. And I said, well, I'll just pick some more middle-based schools. I think I sent out 3 applications, and all of them were turned down. And I was thinking, oh, shit. I get a call from California. A friend of mine's at Stanford. And he said, Bruce, there's a senior scientist position open here. You should come and give a presentation. Oh.
Okay.
The idea from Stanford? I would never have even offered a letter to Stanford. That's like the top of the top, right? Mm-hmm. Now comes it's fun. I show up, I'm going to give the presentation.
The same presentation you did
before? The Stanford one. A similar one because the same idea.
Right.
But no, I had 2 carousels before computer. One had my research on cloning stem cells, which is standard, functional, publishable research. Mm-hmm. And the other one was the new idea. Mm-hmm. My right hand, my left hand. I'm walking up to the projector before the program begins, and my friend who got me the invitation was walking with me. I said, Glenn, which one of these should I use? And he looked at me. It's a no-brainer. You should use the muscle one. You want the job. Use this one. At the projector.
You took the red pill.
I took the red pill. I put the other one down. He looked at me, and I said, well, if I can't talk about this, maybe I don't want to be here. Mm-hmm. Okay, now comes...
Wow, how brave.
This is it's not brave, maybe foolish, so you can't tell the difference. And the program is about to begin, and then I see chairman of pathology, chairman of biochemistry, chairman of the Department of Biology, chairman of radiation at the medical school, I said pathology, and dermatology. Those are the chairmen. And the head of a new organization called Genentech, the genetic engineering firm that was established in the shadow of Stanford, the head of the genetic engineering thing. Every one of these people were genetic researchers. Mm-hmm. And now I'm standing in front of all these genetic researchers, and I'm going to try to tell them who gives a shit about genetics. I'm giving a talk, but I'm getting down to the fundamentals, the mechanism, the membrane, the receptors, the channel, blah, 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 and all that. And my talks are not scripted. They just come in and they go out. And I was writing a conclusion on the board, and I hear these words come into my mind. And I start to laugh. I thought that was pretty funny. I turn around and say it to the audience. I say, if you think genes are the end-all of everything, you're no better than a fundamentalist. Holy shit! holy shit, you should have seen that. They became apoplectic. They were red-faced. They were yelling at me. Why? They're all genetic engineers, and I'm saying it's bullshit. And they're looking at me. The one scene I remember so clearly was one guy started to get up. The guy behind him pushed him down so he could yell at me before that guy could yell at me. I started going, like blowing back, like a wind is blowing me back. And now I'm against the blackboard. And I can't say anything because everybody's yelling at the same time. And I start slipping down. And my belt catches on the chalk tray. My mind says, that's as low as I go. And I yelled back. And the first thing I can remember, but the rest after that was a stream. And the first one was this. Fact, there was life on this planet before DNA. Boy, did it get quiet in that frickin' room. And whatever else I said. And they got quiet. And then comes to the point I was like, thank you very much. And they applauded.
Yeah.
And so I'm still surprised now by this, after this whole confrontational bullshit, that they applauded. The guy who had that position open gives me a piece of paper with what? The names of the chairmen that he wants me to meet with them. And I pushed the paper back. His name was Marv. I pushed the paper back. I said, I think I've wasted enough of their time today. And he pushed the paper back to me. He said, you provoked the hell out of them and they like that. I got the job.
You got the job. That's
I got the
great
job. Research
story.
scientist at Stanford. To do what? Work on my idea in a lab that didn't believe in my idea. Mm-hmm. And when I left, they were continuing my research.
That's a great story.
But boy, I want to tell you that moment of, they're all yelling, and then truthfully, the voice that gave me that little thing that I love to say right then, that little voice is right in the middle going, this interview isn't going well, is it?
That's a great story. Oh, that's so good for you. Oh, wow. My gosh, you've been such a pioneer.
No, it was just, it was fun.
Yeah.
But the more important part comes down to this. Once I understood this, I wanted to bring some people together and tell them a story. And this is another turning point. And I bring them in, and I unload the story of the membrane, the receptors, the environment, the genes, and all that. As if you understand this, you can create the greatest life. And they looked at me and they go, you know, Lipton, for a guy who says that stuff, your life doesn't look that good. I almost said it, and thank God I didn't. I almost said, well, do as I say, not as I do. I was like, oh, that's bad. Mm-hmm. Apparently, I was talking the talk and not walking the talk. Mm-hmm. And it was a wake-up call to me. But to me, it was the wake-up call that said, you cannot go out and talk about this anymore until you actually apply this into your life. You cannot tell other people you can have a great life and your life is not that great. And I thought, if it doesn't work, then I have no more program. Mm-hmm. Universe, thank you very much. It worked instantaneously. Instantaneously, my life changed. Boom. It's like, holy shit, it works. And that was where the rocket started to take off at that moment.
Are you communicating with the universe?
Do I communicate with the universe?
What do you think about prayers?
Prayers?
Or giving thanks to whomever?
That's the difference.
What this
I
is
don't
prayer
give
for
prayer for something I need or want. Mm-hmm. I give acknowledgement to the universe of my appreciation for what I have.
Yeah. That's the difference,
That's
ladies
all,
and gentlemen.
Yeah, the universe has given me everything. The universe has given me all the gifts that anybody could ever imagine. And all I do is acknowledge, thank you. Thank you for letting me have that talk. Mm-hmm. Thank you for, making it work. And thank you, and thank you. That's all. I never asked for anything. It was always given. I didn't have to ask for anything.
And this is something everybody listening to us right now can start immediately, right?
That's it. What you have to do, it's interesting because if I wanted to summarize what was the whole consequence of where it led to, it's called, I think, the Serenity Prayer or something. I can't give it exactly, but it was like, God, give me the consciousness of things that I can do and give me the awareness of things that I can't do. In other words, it's an energy system. And the energy is life. And it says there are things you can fix and you can have involvement with, then engaging with that is okay. But if there are things you can't control or influence in any way, then engaging with it is a waste of your time or your life. It's your energy that you engage. I even use the concept of, talk to people about an energy checkbook. I say, energy is life. That bank account you have? That's energy. The more bank account, the more money, the more energy. The more energy, the more you can do. When you run out of energy, you have nothing. I go, yeah, everybody, you don't write checks for stupid things. You write checks for things that are useful to some degree. Then I say, every behavior in a human is an energy. You need the energy to do any behavior. And I said, what if I gave you a checkbook? And I said, before you commit your energy to doing something, you have to write the check. Because I would say, well, then you start to be very aware of not writing checks for something that doesn't give you anything back. Mm-hmm. You don't write a check to somebody just, oh, Kathy, you're so wonderful. Let me give you $5. Huh? What's that all about? Okay? So all of a sudden it says, you don't do that with your checkbook. Why do you do it with your energy? Because your energy is what the checkbook is actually representing anyway. Mm-hmm. So I say, give you an energy checkbook. Before you commit to doing something, does this in any way support you, your family, or your community? If it doesn't fit in any of those categories, then don't write that check. Okay? I give an example like you can go into a bar and then have an argument over politics and you both are fighting and getting red and heated and using energy. Heat is wasted energy. You get heated, you're wasting your energy, you get all this. And I say, so after the argument's over and you walk out, did you change anything?
And did you feel better after that?
Well, because you lost your energy.
Right.
That was the point. You wasted life to do nothing. And then all of a sudden, that's one of those, don't write that check, man. It's not worth it.
So true.
So that became a real insight to recognize, put your energy in where something can happen, but don't waste it on something you have no influence over.
I thank you so much for this spontaneous conversation. It was a blast talking to you. And
well, thank you for listening to my story, which I always think is fun anyway. It's a fun story to me, and to be here now.
Yeah.
Yeah.
Here and now.
Yeah.
Here we are.
And to live a life that I'm so excited to wake up every day to be here.
I thank you so much. Take good care.
I will wonderfully take good care if I can, because I want more. I'm very greedy about life. I want more.
Mutig, hellwach, blitzgescheit, kein bisschen leise und immer noch hungrig aufs Leben. Und im Oktober diesen Jahres wird Dr. Bruce Harold Lipton 81 Jahre alt. Ich hoffe, ihr habt dieses Gespräch mindestens genauso genossen wie ich. Ich habe ja schon am Anfang dieser Episode angekündigt, dass ich mich gerne bei euch bedanken möchte. Für eure Treue, für eure Loyalität und dass ihr diesen Podcast weiterhin in die Welt schickt, und das seit 200 Folgen. Deswegen gibt's im Monat März für alle Get Happy Hörerinnen und Hörer auf meinen aktuellen Online-Kurs Finde dein unversehrtes Ich 20% Rabatt. In diesem Kurs teile ich meine Erfahrung, mein Wissen rund um das Thema Traumaheilung. 10 Lektionen, fast 10 Stunden Material, ganz viele Übungen für euch, ein umfangreiches Workbook, Meditationen. Ihr habt lebenslangen Zugang dazu. Ihr bekommt natürlich noch die Masterclass von mir zum Thema Selbstfürsorge. Und wenn das interessant ist für euch, dann schaut mal in die Shownotes. Da habe ich euch den Link direkt zum Kurs reingepackt. Der Code lautet Get Happy 200. Auch das steht nochmal in den Shownotes. Und ich würde mich irre freuen, euch auf eurem ganz persönlichen Heilungsweg mit diesem Kurs auch weiterhin noch ein Stück begleiten zu dürfen. Ich danke euch von Herzen. Nächsten Freitag geht's weiter. Dann spreche ich mit Lisa Schuster über die erstaunliche Wirkung von Klangschalenmedizin. So viel schon mal vorab. Es wird sehr, sehr wohltuend. Bis dahin, ihr Lieben, bleibt wie immer zuversichtlich, neugierig und natürlich auch gesund. Bis dann. Tschüss.
Get Happy. Bewusster leben, zufriedener sein. Von und mit Kati Kleff.